So we all know about true north, right? True north is the northern point of the Earth's rotational axis. It is also called geographic north or geodetic north. But where is my true north, say in Mumbai? I am nowhere near the rotational axis. True north is a point on the Earth's surface, permanent, fixed. So from my position to the direction of that fixed point is my true north. Now the same is not true for the grid north. Grid north is not a fixed point anywhere. Grid north is a direction northwards along the grid lines of the map. So my grid north in Mumbai will be a straight line towards the apparent north or the top of the map. So there is an angular difference between the direction to true north and to the grid north, right? This angle is called Convergence Angle. This video is made possible by the members and subscribers of my channel. If you haven't subscribed yet, please know that it will help me in creating this simple, reliable and good content for you. So take a moment to click that subscribe button. Magnetic north is the place where magnetic field lines converge and goes into Earth. We all know that Earth has a magnetic field, right? These field lines generate and comes out somewhere in Antarctica or what we call a South Pole. And these lines converge and go inside the Earth somewhere in the Arctic we call North Pole. Now this is North Magnetic Pole. If you see a bar magnet, the magnetic field lines comes out from the north point of the magnet and goes into the south of the magnet. Remember, these magnetic field lines are curved. It comes out, goes far out, and then it converges in. So from my point on Earth to where all these magnetic lines converge on the apparent north is my North Magnetic Pole. And that's what the compass shows, right? Now there is an apparent difference between the two lines, the direction to the true north and the direction to the magnetic north. And this angular difference is called magnetic declination. You may have heard about dip pole or dip angle, no? Well, as I said above, the magnetic lines are curved, comes out from the south magnetic pole, goes far out in the space and then carve back into the north magnetic pole. So there is always an angular difference between the local horizon and the magnetic field lines, right? This angle is called inclination or dip angle. Inclination changes depending on where you are. If you have a compass needle which freely rotates in all directions, then at North Pole, the magnetic compass needle will point straight down, following the magnetic field lines. Now you may have also heard about a term called geomagnetic North Pole. This is a mathematical model or an approximation of the Earth's magnetic pole. The latest model that we have is called WMM 2020 or World Magnetic Model 2020. This model is very important and it is integrated into our surveying software and navigation software. Why? Because the actual North Magnetic Pole is not reliable and moving at a speed of 55 to 60 km per year. So we need something permanent, something mathematical to define the Earth magnetic field. This is similar to WGS 84 or EGM 2008, which tries to define the shape of the Earth. WMM 2020 is not perfect and needs to change as the Earth's magnetic field and the magnetic north is always moving around. But it's not always easy to hold on to one mathematical model permanently. And that's where the inclination and the declination comes in to help the mariners and aviators. So every map has a declination written in it and how much it is going to change every year. If you want to know more about the declination in your place, you can visit these sites to know more. I will have the website details in the description below. Now here is some interesting fact. If you extend the Earth's rotational axis, it will point towards North Celestial Pole. The star Polaris is about 0.6 degrees from the North Celestial Pole. So for most of the practical purpose, we call Polaris as North Star. But Polaris will not always point towards true north. Earth's rotational axis is kind of fixed locally on Earth, but the axis moves in the celestial sky. This extended line creates a large circle in the sky, and over time, this axis line will move away from Polaris along this circle and point towards another star. In about 12,000 years, Earth's roving axis in the celestial sky will point towards Vega, the fifth brightest star in northern sky. Vega was the pole star in the year 12,000 BCE and will be pole star again in the year AD 13727, and at that time it will be about 3.5 degrees from the celestial pole, close enough to be called a pole star. So in exactly 25,727 years from today, the axis of the Earth will make a large circle in the celestial sky and come back and points towards the Polaris once again. But now, for another 1,000 years or so, Polaris will keep shining as our pole star. So tell me, did we learn something new today? If you want to know how to calibrate your gyro compass at sea, then you can watch this video next. Always be curious and ask questions. Do not forget to like this video.